All right, y'all. So let's have a conversation. I'm gonna try to expose some things that I hope, I really hope go somewhere. So, what is a wave synthesizer?
A wave synthesizer generates sound by using mathematical oscillators to create periodic waveforms like sine, square, or sawtooth. It then shapes these raw sounds using filters, envelopes, and modulators to mimic instruments or create unique electronic textures. Would you like me to explain the difference between subtractive and wavetable synthesis?
Can you use an organ as a wave synthesizer? Analog.
Traditional organs function as additive synthesizers. By pulling drawbars, you combine various sine waves, harmonic overtones, to build a complex sound from scratch. While a pipe organ is acoustic, digital organs use the same mathematical principles as modern synthesizers to generate their tones. Would you like to know how drawbar settings correspond to specific waveforms?
Did y'all catch that? An organ, the organs that they can't build anymore, right? That we see from all these old world, these buildings they call churches, right? Have organs that are they're analog wave synthesizers. Okay, let's see what a wave synthesizer can do. Can a wave synthesizer ring a bell without striking it?
Yes. Synthesizers use FM synthesis, frequency modulation, to mimic the metallic, inharmonic overtones of a bell using only electronic oscillators. By modulating one wave's frequency with another at high speeds, you create a clanging timbre without any physical impact. Would you like me to explain the specific math behind bell tone FM synthesis?
So, stay with me here, folks. We are exposing something that has been hidden from the mass population, right? Share this video out. If this video has sparked you at thus far and it continues to do so, share this video with someone. Let's expose what's going on. Can a wave synthesizer and a giant bell produce energy?
Yes, they produce acoustic energy in the form of mechanical vibrations moving through the air. While this energy is real, it is generally too diffuse to power machines or electrical grids. To calculate the energy of a sound wave, you can use the formula for intensity, I, where P is the sound power, is the area over which the sound spreads. In a theoretical sound-to-electricity setup, you would need a transducer, like a microphone or piezoelectric sensor, to capture the bell's vibrations and convert them into electrical energy. However, even a deafeningly loud sound produces only a tiny fraction of a watt. Would you like to see how much sound energy it would take to charge a smartphone?
Watch this. So, if you had a giant wave synthesizer and a giant bell, what could you get in power output?
To power something significant, you would need an astronomical amount of sound. Even a giant bell ringing at a deafening 120 decibels only generates about 0.01 watts of power per square meter. To put that in perspective, a standard LED bulb, 10W, would require the sound energy of roughly 1,000 giant bells ringing simultaneously at close range. A smartphone charger,
1,000
5W20W,
giant bells.
would require a wave synthesizer loud enough to vibrate the Earth's crust before it gathered enough captured energy to charge the battery. The primary issue is efficiency. Most acoustic energy is lost as heat, and transducers, the devices that turn vibration into electricity, are currently very inefficient at low frequencies. Would you like me to calculate the exact decibel level needed to power a house?
So, I want y'all to think about this. Bells can generate power off a very ultra low frequency, a hum, right? Would get this bell vibrating. Now, when you get this bell vibrating, do you know that the space underneath the bell has levitation properties? With the right frequency, you could lift anything, but you'd have to know that frequency. The old world buildings where these giant bells hung with mercury, Hello? You only need a little bit of electricity with some mercury to get some magical stuff happening. Start putting these together, folks. How would you capture the electricity from a resonant frequency bell?
To capture electricity from a resonant bell, you must use transducers to convert mechanical vibrations into electrical signals. Primary methods: piezoelectric sensors. Attach crystals to the bell's surface.
Piezoelectricity.
As the bell vibrates, the physical stress on the crystals generates a high voltage, low current electrical charge. Electromagnetic induction. Place powerful magnets near the bell's rim with stationary copper coils nearby. The bell's metal moving through the magnetic field induces an alternating current, AC, in the coils. Acoustic metamaterials. Use specialized chambers designed to focus sound pressure onto a small diaphragm, which then drives a tiny generator. The power reality. Even with a giant bell, the output would be milliwatts. You would need a bridge rectifier to convert the chaotic AC pulses into stable DC, and a large capacitor bank to store the energy for any practical use. Would you like me to design a simple circuit diagram for a piezoelectric energy harvester?
Could a giant building built of heavy quartz crystal stone be used as a resonant captivator of this energy?
In theory, a quartz building acts as a massive piezoelectric transducer. As sound waves from the synthesizer or bell hit the walls, the structural stress would squeeze the quartz, generating an electric charge. However, the giant scale creates a physics trap: stiffness. Heavy stone requires immense pressure to deform enough to produce electricity. Damping. The building's mass would likely absorb and dissipate the vibration as heat before it could be harvested. Voltage versus current. You would get high voltage sparks but almost no usable amperage flow, making it more like a giant static electricity generator than a power plant. Would you like to explore how resonant frequency could eventually crack the stone instead?
Interesting. The resonant frequency could crack the stone instead. What would happen if your wave synthesizer rang the bell at an uncontrollable rate?
If the synthesizer matches the bell's resonant frequency without stopping, the bell will eventually shatter. This happens through constructive interference, say, where each new sound wave adds to the physical vibration of the metal. The breakdown. Mechanical stress. The amplitude of the vibrations increases until the metal's elastic limit is exceeded. Structural failure. Microscopic fractures spread instantly, causing the bell to crack or explode into shards. Energy feedback. In a quartz building, these vibrations could trigger high voltage electrical arcing before the stone itself structurally fails or spalls. Would you like to know the math behind calculating a material's breaking point via resonance?
You don't say. So let's get this right. All these buildings are laid out mathematically based off resonant frequency, right? They've turned the building into a giant transducer. How could you capture the energy from the resonant bell wirelessly?
To capture energy wirelessly from a vibrating bell, you would use acoustic to electric induction or resonant coupling. Acoustic rectennas, specialized antennas tuned to the specific frequency of the bell's sound waves, capture the pressure and convert it into a radio frequency, RF signal, which is then rectified into DC electricity. Magnetic coupling. If the bell is made of a ferrous metal, its vibration creates a moving magnetic field. You can place an induction coil nearby, but not touching, to catch the electricity through the air. Laser vibrometry. A laser beam reflects off the vibrating surface. The shifting light frequency, Doppler effect, can be converted back into electrical data or energy at a distance. Would you like me to explain which frequency range is most efficient for wireless energy transfer?
So, on the buildings that are these resonant frequency generators, we see patterns. Those patterns line up with the very resonance of those buildings. It basically is the instructions on how to operate them. You understand? Those buildings are tuned to a certain resonance with a certain bell. The building is the transducer, the copper that you see running all the way up, the metal that runs all the way up to the top. these giant organs that were an analog compressed air to create a resonant sound that would ring a bell that never had been struck. Many of the old world bells had no bell ringer. They had no dents on it like it had been hit. Why? Because they were using sound to ring the bells. And you could ring a bell for hours. And this bell, if you got the right distance, right, you could have another tower that had another bell that would start slowly picking up the resonance and building up the energy. Okay? And then another distance, you'd have another bell. Funny. You go look at all the old world, right? They took all your bells away. Ring your bell. Just kidding. All right. So, I want y'all to think about this. Everything that I just covered is scientifically proven, right? History books are lying to you. Your government's lying to you. The whole world's governments are lying to you. Don't even get me started how we all get along in Antarctica, but, you know, on the world stage, right, we don't get along. It's all a lie. Wake up, folks. If you're watching this, you are the revolution. So, the bells. Go do your research. Go do your history. Millions and millions of bells. You'll see that they would stack these bells for miles. Bell tower, bell tower, bell tower, bell tower, bell tower. Right? Creating energy on massive levels. And they actually left you the instructions, what frequency you need to play. Right? The organs don't work. Right? We can build a wave synthesizer to replace those organs. We can build a digital wave synthesizer, not an analog. Better yet, share this video to someone and reach out. If y'all want to play with some science stuff, hit me up. It's all in our face, you guys. Watch this. Theoretically, if you had the right amount of power and the right wave synthesizer and a bell big enough, could you lift anything?
Yes, you can lift objects using acoustic levitation. By using a powerful synthesizer and a massive bell to create standing waves, you generate high-pressure nodes that can counteract gravity. How it works. 1. Pressure gradients. The sound waves create areas of intense air pressure. 2. The trap. Objects become trapped in the nodes, valleys, between these pressure peaks. 3. Lifting. By shifting the frequency or phase of the synthesizer, you can move these nodes upward, carrying the object with them. While current technology only lifts small droplets or light foam, a giant system would theoretically scale this force, though the sound intensity required would likely be lethal to anyone nearby. Would you like to know the decibel level required to levitate a human?
So, we know, right, that with such mastery of sound, you can play sound back at sound and eliminate it, right? The deadening effect. They were using this technology, right? They would actually ring simultaneous bells to stop the detrimental force of this being spread, right? Now, if something went wrong, right, you could have a systematic failure, like almost like a runaway at a nuclear plant, right? Very much the same thing, almost analog style, not so much the digital part. Can you fuse atoms with sound and vibration?
Yes, this is known as sonofusion, or bubble fusion. It uses high-frequency sound waves to trigger acoustic cavitation, causing tiny bubbles in a liquid to collapse so violently that they generate intense heat and pressure. The process, cavitation. A wave synthesizer sends ultrasonic pulses through a deuterated liquid. Collapse. The bubbles implode, theoretically reaching temperatures of millions of degrees. Fusion. In this localized hotspot, atomic nuclei may move fast enough to overcome electrostatic repulsion and fuse. While researchers like Rusi Talyarkin claimed success in 2002, the scientific community remains skeptical, as the results have been notoriously difficult to replicate reliably. Would you like to explore why maintaining the bubble's stability is the biggest hurdle for sonar fusion?
Theoretically, you could melt stone with that, right?
Yes, you can. High-intensity sound creates friction and pressure that converts into heat through acoustic absorption. In a resonant system, the mechanical stress would generate enough internal heat to reach a stone's melting point, typically 1,200 degrees Celsius to 2,400 degrees Celsius. However, the stone would likely shatter from structural failure before it turned to liquid. Would you like to know the wattage required to liquefy granite?
So, I want y'all to think about this. It's been a 15-minute video. I'm going to end this one here. More to come. You know, normally I'm talking about, what Jesus has done for me and how he saved me. But there's a lot more to me than just that. And this is something that's been heavy on my heart. Been studying this stuff for years, and I truly feel that the people of the world are ready to know what they don't know. So help me share this message. If y'all got questions, want to come peek behind the veil, hit me up. God bless y'all. Have a blessed day. And until next time, stay dangerous.